actually created a one local variable there as a time consumed, and I'm consuming it over the main class. Okay, I just wrote a simple code. So I have executed it, and you can now check it. So what happened, and what I did also, I also changed it to 1 million records. Okay, so we are again working on 1 million records. So when I'm going to run it, what you can observe, that while running it, you can observe that it is going to take 29 milliseconds, okay, in order to evaluate that one that records of that's records of 1 million entries, okay, in order to evaluate it. Okay, now let's do one thing, let's change it to parallel stream. Okay, so it's a parallel stream. Okay, now let's verify it and figure it out that how much time it is going to take it. Parallel stream is means two streams are executing parallelly. Okay, instead of relying on the one streams, now we are going to work on the multiple streams. Okay, so now let's execute it. Okay, now it is taking 64. Okay, wait a second, now why we are getting the higher thing? Okay, this is again the main interview questions. So wait a second, let's execute and let's understand the both the things. So instead of doing it in a same application, what I'm doing, I'm changing this approach and writing it that same code again in the as a separate method in order to calculate the time. Okay, just a second, just give me one thing. So it is like filter passport based on status, and this one is through parallel stream. Okay, control V, parallel stream. So what I'm doing, first of all, just remove it to stream. Okay, and this, so time consumed, stream, and control C and control V, and this time control, it's parallel. Okay, what is that spelling? Control C and control V, sometimes these things happens. So okay, so this one is this, just a second. So this one is time consumed stream, and this time consumed through streams, and these time consumed through parallel stream. Okay, so these are the two variables which I am going to execute right here. So just a second, sorry. So this one is this status, control C and control V, and right there again what I'm doing, this one is list of 2, and this time I'm using parallel stream, and again list 2 I'm going to display blacklisted stream list 2 dot size, and this time I am printing the time consumed by parallel stream. Okay, parallel stream. So I am not printing the whole data. Instead of printing the whole data, I am just displaying the size returned. Okay, so let's run it. So here both the entries are fine, but you can observe right there that parallel streams taking much more time. Okay, now the interview question can be that why it is taking much more time, right? So basically this is a top notch interview question, and the basic answer is that concurrency is not always making your code faster. Okay, sometimes it makes your code slower also. Why? Because it is not all about the volume every time. And to be very honest guys, this is a very important part, and I think that you should not skip this part. Okay, so the answer is that it is not always depends upon to the volume, right? The kind of the volume of data you have. Sometimes, and usually it basically happens that what type of the operation you have. So checking that simple operation, that filter blacklisted is equals to true, is not that complex, and instead of doing that, our processor have to do much more complex task, that is context switching between the multiple threads, right? So in the parallel processing, our processor is engaged more in context switching, and it would be better that rather than switching the threads from one to another, it's better to rely on a one thread and perform its operation. Okay, so that is the benefit, that is a benefit of or you can consider that that is basically the task. So threading is basically, or threading should be applicable in kind of a way where business operation is much complex. Okay, it is having a lot of workload, and in order to resolve this workload, we are trying to execute multiple threads in the different cores. Cores means 8 core, 4 core, 16 core of the system. Okay, in the previous video we have discussed about that cores as well, but right there threading is not giving us the full benefit. Why? Because our application, our objective, our operation is very simple, and we are wasting the CPU, you know CPU energy in context switching rather than doing the operation, the relevant operation what we want, or rather than doing the business operation, we are engaging our CPU more into the context switching. So I hope that you have understood the Stream API and the concept behind it, that how and in which scenario you should use the parallel streams and when it will actually helps you out. This is a top notch interview questions, participants, and even though what I have observed that many of the experienced developers are not able to answer such questions efficiently, and they usually fails the interview. I hope that you have liked this video. If you have watched this video till here, I expect you to subscribe my channel, and do tell me that what type of other videos you want me to make. Although my objective is that gradually, as I am getting time, I'll try to make all the videos of the all topics, including the entire Java full stack. But rather than focusing on the conventional chapter by chapter approach, my 100% approach is towards, in order to resolve your issues and discuss the top notch interview questions what we usually ask through the candidates during the interview, so that you can also get the benefit of clearing the interviews. Thank you, participants, for watching my video till here. Thank you.